Hello guys, welcome to my YouTube channel, and today we are going to continue with the SQL interview questions. So in the previous lecture in the previous video we had covered basic 5 questions, that is what is SQL, what is database, some commands, and then select statement, and what is a join. Okay, so let's continue with the 6th question, that is differentiate between inner join and left join. Okay, so what is inner join? Here you can also add the right join because it is connected with left join. So let's understand. Basically, in brief, I can explain you that inner join returns only the common elements of both the tables. Okay, and left joins returns all the elements from the left table and matching from the right table, and the right join does vice versa of left join. Okay, as simple as that. Okay, so let's understand this using a practical implementation. Okay, so I'm going to use the database, that is employee. Okay, and then I'm going to use select star from job details. Okay, so here there are two tables, one is details and job details. Okay, so here you can see the job details like this. So employee ID, job title, department ID, start date, and also here you can see there are 8 rows. Okay, for job details. Okay, now there is another column, that is details. Okay, so it has around 17 rows. Okay, so keep this in mind, that is 8 rows for job details and 17 rows for details. So basically there is like the number of rows are different in both tables. Okay, so if you do inner join, okay, so let's do inner join. So select star from let's take details first. Okay, so details has 17 rows. Okay, and let's use an alias d. Okay, and join. Okay, we are going to use inner join. What we are joining? Job details. Okay, so job details, let's use alias j here. Okay, on what we will use here is employee ID. Okay, so d dot employee ID is equal to j dot employee ID. Okay, so now here you can see that the number of rows returned will be, I think, 8. Okay, so let's have a look. Yeah, 8 rows are returned. Why? Because the employee ID, that is 1 2 3 4 5 6 7 8 and 1 2 3 4 5 6 7 8 is the only ID that is common in both the tables. Okay, so it is returning all the data from the left table with respect to those employee ID, and all the data from the right table with respect to those employee ID. Okay, so this is inner join. Okay, so basically it is returning all the common elements from both the tables with respect to employee ID. Okay, so this key represents whatever elements that are common with each other. Okay, so it is returning all the common elements which has the same employee ID. Okay, these. Okay, so this is inner join. So if you use left join, just replace the inner word with the left. Okay, now what happens here is it will return all the data from details table, and like all the data from details, and whatever common is there, it returns from the job details. Okay, so let's look into that. So basically you will get 17 rows on the left side. See, on the left table you got 17 rows, and you got null everywhere where there is no data. Okay, and here you can see everywhere that there is null, basically wherever there is no related data after 8, because in inner join we considered up till 8, right? So after 8 everywhere it is null in case of right table, and here since there is some data in the details table, it is returning those things. Okay, because I think we added only country ID in the details in the previous project. Okay, so you can also look into that project, because this employee project or employee database, some queries we had solved using OpenAI. Okay, so there might be some mismatch in the data because that was in progress. Okay, so yeah, to learn and understand left join, this is better. Okay, now if you do the right join, what happens here is we will still get only 8 records, because the right table has only 8 rows, and corresponding to that we will get the left table. Okay, that is how it works. Okay, so this is right join. So hope you understood this. Don't get confused because some things might be present, some things might not be present. So just look at the table structure. Okay, sometimes you may find that inner join and right join are similar, but they are not. Okay, since the elements or the common key elements are same in both the tables, so it is returning the same kind of data. Okay, that is the thing. But the data will not always be same in case of organizations which you are working on, because it will be more and more complex kind of data. So you will understand in this when you are actually working on a project. Okay, but to just for the understanding's sake, you can consider that inner join gives the common elements, left join gives all the data from the left table and the common elements which are matching to the left table. Okay, and it replaces null where there is no data present with respect to the left table. Okay, so if I go on with this, you will go and get confusing. So just implement this, you will understand. Okay, so this is left join, right join, and inner join. Okay, and yeah, if you want to do just let me do one more thing. Group by is there, index is there, normalization is there. Okay, so let me give you the understanding of the outer join also, because in case of this like the full join, it doesn't work in case of MySQL Workbench, because it is giving the similar what you can say similar kind of records in case of inner join and left join, or you can say just join. Okay, so to understand that, we need to use union and union all here in case of full join and full outer join. Okay, so what happens here is first you need to take the here you can see the right join I have taken. Now you can take left join here. So basically what we are doing here is to like get all the elements, like just the full join you can consider. Okay, so we will be using union command here. Okay, so now what happens here is in case of full join, what we will get is you will get all the elements from both the tables. Okay, so you should get all the records from the left table, that is 17, and all the 8 records from the what you can say right table, that is 8 records. Okay, so to do that, first you need to do left join. Okay, so that we can get the details of all the tables, and union in the sense it will give all the common elements. Okay, and you can do right join on the right table. So what happens here is, okay, just let me give you the output here. So here you can see 17 rows have been returned here. So that is union. Okay, so it gives 17 records from here and common records from this, that is 8. Okay, but now if you do full join, that is union all, or you can consider the outer join. Now here's the confusion. Okay, there is a join statement. Basically it will give you the all the common elements from both the tables. Okay, and there is full outer join. Okay, that will give you the all the elements including non-common. Okay, so now union all acts as that. Okay, so if you do this, you will get 25 records now. So what happened here is you get 25 17 from this and 8 from this. Okay, so 17 plus 5 is how much? 25. Okay, so this is full outer join, and the previous one was just the join, like outer join. Okay, yeah, that's the scenario in case of MySQL Workbench. Okay, so in case of other things, I think they use only outer join or just the join. Okay, like that. But in case of MySQL Workbench, you need to use union and union all. Okay, to understand that. So don't get confused here with respect to join, just like full join and full outer join. Basically full join is common elements of both the tables, and full outer join is all the elements including both the tables. Okay, yeah, so that is the joins. Okay, now explain the group by clause. Okay, so group by is used to group the rows based on some common values. Okay, so let's understand this. Okay, so I will be using what we will use. Okay, let's use the job title, or Yeah, let's use job details for group by. Okay, so let's see what is there here first. Okay, job title is there. Okay, so let's, because software engineer is twice here. Okay, also sales representative is twice, so let's group them out. Okay, so that is how you can use group by. Okay, so select job title and count of job title as count from job details. Okay, and what we'll do, group by job title. Okay, so this will give us the group by statement. Okay, so if you execute this, you will see that software engineer is twice, sales representative twice, marketing manager is once, research scientist is once, and others are also one. Okay, here we can also use the order by clause. So order by, you can use count. So first, like default, it will be in ascending order, so now it will go reverse. So 1 1 1 1 and lastly 2 2 2 2 2. Okay, so this is how group by command is used. So basically, for grouping things out, you can use group by command. Okay, now the next question is, can you name some SQL constants? So basically, there are some constants which are like default. So sets a default value for a column. That means if it don't pass any value for the particular column during the insertion, it will take the default value. And if you add unique constraint during the table creation, it ensures that only distinct values are allowed. That means no duplicates. And this allows you to like requires value to be not null. That means no null value is allowed in the table column. Okay, and primary key enforces the uniqueness and non-null values. Okay, so if you initiate any column with primary key, it ensures that it is not null and also unique. Okay, and then foreign key, it establishes a connection between multiple tables using shared keys. Okay, so these are some constants you need to remember in SQL. Okay, now what are indexes in SQL? So an index is a database object used to improve the speed of data retrieval operations in database table. Okay, so there are two types of indexes, like clustered and non-clustered. Okay, so you can look that out. Now the last question of today's video is, or lecture you can consider, that is explain normalization and its types. Okay, so there are different normalization, like this is used to organize data in our database to reduce redundancy in the sense repetitions. Okay, so to do that we use normalization. So there are different normalization forms, that is first, second, third, fourth, fifth, and one more is there with the name, I think B, it starts with B, what is it, yeah, voice code normal form. Okay, so let's have a look in this so that you will understand this. Okay. So what is first normal form? So don't need like you can also read this, but here you can see first normal form, you need not have these kind of things in the table. That means you need to separate, if a column has two things separated with a comma or anything, you need not have this. Okay, so after separating this like this, John Smith math, John Smith science, you can see John Smith math and John Smith science, and also grade is AA. Okay, so now this is in normal form, first normal form. Okay, so this is not allowed. Okay, now for second normal form, what happens here is we need to have the table first of all in the first normal form. Okay, and after that there is one sentence here, there should be a partial dependency exist like when a non-primary key column depends on only part of the composite primary key. Okay, so here you can see that these are the primary keys, basically order ID and customer ID. Now the price depends on the product, right? Okay, and product depends on these primary keys. Okay, so there is a dependency on what you can say, where is that statement? Here you can see they have given explanation. The table is not in second normal form because the price column is functionally dependent on only part of primary key. Okay, that is product. Okay, so this is dependent on this. Okay, and not on the whole primary key, and this is not depending on this. Okay, so to do that we need to have this in separate table. Okay, and other things in separate table. So we will have order ID, customer ID, product, and quantity. order ID, customer, product and quantity, and price and product will be indifferent. Okay, now this is in second normal form. Okay, that means there should not be a dependency of this, like the partial dependency on this, and this like this has no dependency on primary keys, but rather it is depending on product. Okay, like that. Now in the third normal form, it is similar scenario, but like here there is a statement where it is okay. Here this table is not in third normal form because the transitive dependency between the manager column and department column, where is not yeah, this one. A transitive dependency exists when a non-primary key column depends on another non-primary key column. Okay, now for example, here you can see a table name employees that stores information about employees. Okay, in this table the manager column depends on department column. Okay, so this manager column is depending on department column, and neither of them depend on primary key employee ID. Okay, so this manager column depends on department column. Why? Because there can be different departments which has the same manager, right? So this is depending on departments, but department has no connection with employee ID, right? So these two are not depending on the primary key. Okay, so these two can be separated. This is third normal form. Now this structure is proper in third normal form. Okay, this does not satisfy the third normal form. Okay, that is how you should go with that. Okay, now the Boyce code normal form is like you can read it out. Okay, so it addresses the issue of non-trivial functional dependencies. A functional dependency is said to be non-trivial if it doesn't hold true for the case where the left hand side is a subset of the primary key. Okay, now for example, let's say we have a table named invoices. Okay, so let's say this table is named invoices, that stores information about the invoices of the company. Now this table does not satisfy this Boyce code normal form. Okay, now in this table the primary key invoice number, so this is the primary key, and it has non-trivial functional dependency customer ID and product. Okay, and this dependency doesn't hold true for the case where the left hand side of the subset of the primary key, because the product can be different for the same customer, so the table is not in Boyce code normal form. So this product can be same for like what you can say, it can be same or different for the same customer. Okay, so that is why it is not in Boyce code normal form. Yeah, so to bring this table in Boyce code normal form, we need to separate the table into two separate tables, one for invoices and one for customer product. So now there will be invoice number, quantity and price, invoice number, quantity and price, and customer and product will be indifferent. Okay, so whatever, now all the normal forms you can consider like whatever columns are depending on each other rather than depending more on the primary key are separated like that. Okay, so invoice number, quantity, price, and customer ID and product are separated. Okay, okay, also you can read this out. Okay, I'm just explaining in brief. Okay, and now fourth normal form is like higher level of normalization in Boyce code normalization, and it addresses the issue of multi-value dependencies. A multi-value dependency is a type of dependency where a non-primary key column is functionally dependent on two or more independent non-primary key columns. Okay, for example, you can consider that this is the orders table which stores information about orders. Okay, and this table is not in fourth normal form. Okay, now there is multi-value dependency between product and supplier. Okay, here you can see A is supplied by supplier S1 and B is supplied by S2. Okay, so this is like A is supplied by same supplier. Okay, so this is multi-value dependency. Okay, so that we need to separate. Okay, so here you can see product and supplier is separated. Okay, and order number, customer and product is in different table. Okay, so this is the fourth normal form. Now fifth normal form is not used that much, but yeah, just let's understand this. So this addresses issue of joint dependency, and a joint dependency is type of dependency where a table can split into two or more tables. Okay, so fifth normal form basically takes more and more space, I think. Okay, so each of which contains a subset of the original table column, and it can be recombined by joining the tables on their common columns. Okay, okay, so let's say the employee database is there. This is not in fifth normal form because this is employee ID, employee name, department and salary. Now what you can do is employee ID and employee name can be in one column, department and department salary will be other column, and department itself can be another column, like that. So here you can see there is employee ID is completely dependent on employee name, department is not depending on any other name because it can be connected with these tables, this table using join. Okay, so employee ID, department and salary, like that. Okay, so this is how it is separated. Now here you can see three tables are formed, so more and more tables will be formed. So this eliminates joint dependencies and improves the data integrity and consistency by reducing the data anomalies. However, it is not often used to practice as it requires large number of tables and it can be difficult to maintain. Okay, so fifth normal form is like it is difficult to maintain and it increases the complexity. Okay, so most probably the basic requirement is like the first normal form should not be the table should be in first normal form, because this should not happen. Okay, so that we can differentiate, like, or you can do calculations in a better form. And then comes the second normal form, like the partial dependency is there between the primary key and the product, then no dependency between primary key and the product, third normal form. Okay, then Boy's code has subset dependency like this. Okay, and fourth normal form is like joint dependency, like multi-value dependency, sorry, and fifth normal form is like joint dependency. Okay, so yeah, so that's about the normalization. Okay, so hope you learned and understood something from this video. If you do hit the subscribe button. Until then, take care, bye bye.